The single greatest skill I have picked up for my professional career has been learning how to code. The benefits of learning to code can be surprisingly wide-ranging. One of the strongest and most obvious draws of learning to code is the earning potential, as programmers tend to earn above average salaries. Also, the demand remains strong for coding-related jobs, so there is plenty of opportunity in the arena. One major effect of learning how to code or program is teaching yourself how to think critically and ultimately make you a more flexible candidate in a rapidly shifting digital economy. Welcome, rock stars! I am your lecturer, Doron Williams, and I'll be guiding you through Introduction to Object-Oriented Programming. In our first module, we will define the object-oriented programming paradigm, which we will begin referring to as OOP, and highlight how it differs from procedural programming. We will discuss the different approaches to OOP, and then I'll demonstrate to you how to set up your work environment on your PC to begin programming in C++. From there, we will discuss the basic syntax of the language, the statements, and flow control. Then before wrapping up the module, we will demonstrate our knowledge by writing basic C++ programs. So let's get started. Now we'll take a look at the differences between procedural and object-oriented programming. The procedural method. Now, object-oriented programming was developed because limitations were discovered in earlier approaches to programming. And this procedural method makes a program's structure difficult to conceptualize and modify. When data items are modified in a large program, it may not be easy to tell which functions access the data. And even when you figure this out, modifications to the functions may cause them to work incorrectly, with other global data items. Everything is related to everything else. So a modification anywhere has far-reaching and often unintended consequences. The more important problem with the procedural paradigm is its arrangement of separate data and functions, and this does a poor job of modeling things in the real world. So in the physical world, we use real objects such as people and cars. With the object-oriented approach, the fundamental idea behind it is to combine into a single unit both data and the functions that operate on that data. When you define a class, you define a blueprint for a data type. This data type is referred to as an object. In addition to program operation, OOP also deals with the overall organization of the program. Complex real-world objects have both attributes and behavior, and such objects aren't like data and they aren't like functions. The fundamental idea behind OOP is to combine into a single unit both the data and the functions that operates on that data. As it turns out, attributes in the real world are equivalent to data in a program, and they have certain specific values. Some characteristics or examples of attributes are eye color and job title for people, and also horsepower and number of doors for cars. Behavior is like a function, and functions issue commands. For instance, accelerate or decelerate, blowing the horn, or turning headlights on or off. When you define a class, you define a blueprint for a data type. Now, this doesn't actually define any data, but it does define what the class name means, and that is what an object of the class will consist of and what operations can be performed on such an object. So OOP really deals with the overall organization of the program. Programming objects in a real-world scenario is the happy result of combining the data and the functions that work on this data. In OOP, objects are members of classes, and a description of similar objects are related to these classes. An object is often called an instance of a class, and a class is reusable. So once a class has been written, created, and debugged, it can be distributed to other programmers for use in their own programs. This is called reusability. Now let's take a look at the C++ language itself. Now C++ is a cross-platform language that can be used to create high-performance applications. It was developed by Bjørn Stroustrup at Bell Labs as an extension to C starting in 1979. C++ adds many new features to the C language and is widely regarded as a superset of C. It is a multi-paradigm programming language that supports procedural and also object-oriented and generic programming. C++ excels in situations where high performance and precise control over memory and other resources is needed. So here we have some examples at some of the use cases of C++. It can be used for embedded systems, operating systems, video games, network applications, audio and video, and even graphics and animation rendering. Now, what is the compiler? Now, because a computer can only understand machine language, which consists of zeros and ones, and humans wish to write in a language that the computer can understand, these high-level languages have to be rewritten or translated into machine language at some point. This is done by special programs called compilers, and they are also known as interpreters or assemblers, and these are built into the various programming applications. C++ is designed to be a compiled language, meaning that it is generally translated into machine language that can be understood directly by the system. This makes the generating of the program highly efficient. The C++ processor copies the contents of any included header files into the source code file, and then this expanded source code file is compiled into assembly language appropriate for the platform. The assembler code generated by the compiler is assembled into the appropriate object or macro, and this can be cross-platform, so it may work on either Windows, Mac, or Linux. Now let's take a look at some of the major components of compilation. So we see here that the C++ preprocessor copies the contents of any included header files into the source code file. And then, as I said before, it generates the macro code and replaces symbolic constants defined using the hashtag define with their values. The expanded source code file is then produced by the C++ preprocessor and is compiled into assembly language appropriate for any platform that you are running the software on. The assembler code generated by this compiler is then assembled into appropriate object code. The object code file generated by the assembler is linked together with the object code files or any library functions and is used to produce an executable file. Now let's take a look at how to set up and install C++ and an integrated development environment on your machines. So with a typical C++ IDE, you get a code editor that does line numbering and syntax highlighting. Many, but not all IDEs include a C++ compiler and a linker. So the ID, or IDE rather, will know how to interface with your machine in order to convert your source code into an executable file. And when you need to debug your program, you can use the integrated debugger. Furthermore, IDEs typically bundle a number of other helpful editing features, such as integrated help, name completion, auto formatting, and sometimes a version control system. So while you could do all of these things separately, it is much easier to install an IDE and have them all accessible from a single interface. So in this slide, I have included a link, and if you follow the link, it will take you to the page where you can set up an IDE to begin programming or writing your first program in C++. So let's have a look. Now, for the purpose of this course, I highly recommend Visual Studio for Windows. So if you're developing on a Windows machine, which most of you might be, and disk space and download size are not a problem, I strongly recommend Visual Studio Community. So when you run the installer, you'll eventually come to a screen that asks you what workload that you'd like to install. And you can see here that it's highlighted. You should choose desktop development with C++. So if you do not do this, then C++ and its capabilities will not be available. So when you click this link here, Visual Studio Community, it will take you to the download page, and all you have to do is click on the free download, and then once you run that installer, it will take you to this page. And like I said, just select the desktop development workload for C++, and it will download and install all the C++ components that you will need for the remainder of this course. So I will see you in the next video, where we will write our first program and get started with our development. We'll now explore the anatomy of a C++ program. So if you want to comment multiple lines, you can do it using the / and star. And you can end that comment by using the star and /. Now you use the / if you want to do multi-line comments. If you would rather do a single line comment, you may also use the double /. Now comments are used for brief explanations or descriptions of a code snippet. In the next line, we'll see here that we have a hashtag sign, and a hashtag in C++ is a directive which is read and interpreted by what is known as the preprocessor. Blank lines have no effect on a program. They simply improve the readability of the code. The next line tells the compiler that we're going to write or define a function called main. The open curly brace indicates the beginning of main's function definition, and the closing brace indicates its end. Within the function block is the first statement that will execute when we run our program, followed by a return statement. Okay, so now it's time to fire up Visual Studio. Now that you have it installed on your machine, we're going to open it up, and we're going to select Create a New Project. We can search for our C++ project template, and what we want to select is the console app, right? So you see here, we will be running code in a Windows terminal, and by default, it prints Hello World, right? So just ensure that you have C++ and that it is a Windows console application, and you'll want to click Next. Now let's give our application a name, and I'm just going to call it Intro OOP, and click on Create. Okay, so once you have done that, you will get this C++ program right out of the box. So here we can see that it has several comments. This first line just simply tells us that this file contains the main function, which we can find here. And program execution begins and ends with our main function. It also lets us know that we can run our program by pressing the control button plus F5 to start without debugging. And if you want to debug your program, you can run your program by hitting the F5 key. And it also has some other tips for getting started here. I'm just going to go ahead and delete all of this. But before we delete anything, let us just simply run our program and see what we get. So I'm going to press Control and F5 to run our program. And here you can see it prints Hello World to the console. So it's working as expected. So let's close that. Let's remove some of these comments. And let us format this program to look a little bit more like what we had in our example. So I'm going to use the multi-line comment. And I'm going to put my name. And program description. So this is a program that prints text to the console. So here you can see we have our include directive, and it's including our IOStream header file. Here we have our int main function, and inside of our int main function we have our cout and our insertion operator. And basically what this is doing, it is inserting the string to the right of the operator into this cout function. So that is what allows us to print text to the screen. Now I'm just going to put a return. Let's undo that. Return 0. As you can see, the program ran just fine without it. However, I just like to put return 0 since it's an int that is defined as the return type for this function. So now, what I would like to specify, I'd like to put a single line comment here that says the main function begins and this is where our main function ends. All right, so remember, the program will ignore anything that is a comment, anything after the // or between the multi-line comment. So let's just modify our string a little bit. All right, so we've added some extra text to our string. So now let us run it again, Control plus F5. And you can see that it has now printed our entire string. Hello world, learning C++ is easy and fun.